So in the previous video, we talked about symmetric functions. What is symmetry about x-axis, y-axis, and origin. So in this video, we are going to talk about even function and odd functions. So what is an even function? Even function is a function which is symmetric about y-axis. Now, what is the symmetry about y-axis? If x is replaced with minus x in the graph, and the graph remains unchanged, then f of x is said to be symmetric about y-axis, and if it is symmetric about y-axis, we will call it an even function. So let's check out an example. If you look at this graph, you will immediately see that this graph is symmetric about y-axis. So for every point xy that lies here, the point minus xy also lies on the same graph. For that reason, we say that if we replace x by minus x, the graph still remains the same or unchanged. So every symmetric about y-axis graph is also called an even function. So we mathematically we can check that if a function is even or not. So if a graph is given to you like here, y equal to x square, and you have to check that if it is an even function or not. This is what we have to check. Is it an even function? So we will replace x by minus x like here, and this gives us just x square. So we got back the same graph. So in this case, we will say that y equal to x square is an even function. Yes, an even function. Let's try another graph. Y equal to, let's say the simple one, x cube, and we want to check that if it is an even function or not. So again, we will replace x by minus x cube. This gives us y equal to minus x cube. So we started with y equal to x cube, and the graph here is changed. So we will say no, not an even function. So the graph y equal to x cube is not the graph of an even function. So then what would be an odd function? So an odd function is the one which is symmetric about origin. In the previous video, we saw that what graph is symmetric about origin. How do you check that if a graph is symmetric about origin? So if you replace x by minus x and y by minus y in the graph, if you replace x by minus x and y by minus y in the graph y equal to f of x, and it remains unchanged, then the graph is called symmetric about origin. And if it is symmetric about a region, we will call it also an odd function. Let's check it through an example. We have a graph y equal to x cube minus x. We want to check that if this graph y equal to x cube minus x, an odd function. So let's replace x by minus x by definition and y by minus y. So in the place of y we have minus y, in the place of x we have minus x minus x. Let's simplify this. Minus y minus x cube plus x. What I'm doing here is I'm bringing this negative on the other side. When this negative multiplies inside, you get x cube minus x. So we started with y equal to x cube minus x and we got back y equal to x cube minus x. If we get the same function back after replacing x by minus x and y by minus y, we say that the original graph y equal to x cube minus x is an odd function. Let's try one more example. Let's check if the graph for y equal to square root x is an odd function. So let's replace x by minus x and y by minus y. So when we do that here, minus y square root minus x. After simplification, it gives us minus on the other side. So we started with y equal to square root x and we got y equal to minus square root minus x. Since this minus inside the square root cannot come out, so we got a different graph. We will say that now y equal to square root x is not an odd function. So if it is not an odd function, then is it an even function? So we are going to check that if y equal to square root x is an even function. So by the definition of an even function, it should be symmetric about y-axis, and to check the symmetry about y-axis we replace x by minus x, and we do that here. Y is equal to square root minus x. We cannot simplify this anymore, so we started with y equal to square root x and we got y equal to square root minus x. So a different function, if it would have been a same function, we would call y equal to square root x an even function, but it's not the case here, so we will say that now y equal to square root x is not an even function. So what we have deduced here is that y equal to square root x is neither an even function nor an odd function. So we are stopping here. In the next video we are going to talk about what is an inverse function and how do we find the inverse of a function.